Okay, so we're going to solve some trig equations today, and I have a few that I want to go over. We'll start with some simpler ones and we'll work our way down. We'll do a few and maybe we'll stop the video and so that you can get your brain wrapped around those ones and maybe do a couple of different videos instead of trying to do a big marathon in case you want to go back and look at some of these. It'll be easier for you to go back and find them if you only have to, go back for a couple equations. So we'll start with this one. We're solving the equation. So solve means the same thing it always does. We're trying to find the value of x that would make this expression true, or whatever the variable is. Solve means find the value of that expression that makes it, that variable that makes it true. So that's what we're doing here too. We're trying to find the value of that x that is going to make this true. In this case, it's an x. All right. Now we're going to solve this just like we would any other equation. So if I had an equation that looked like this, we would all know that the first step that we should do would be to collect all our x's on one side, and we would add x to both sides. And we would get 2x, and then I would bring this back over to this side is equal to negative square root, right? So if I'm thinking about a trig equation, I'm going to be doing that same thing. I'm going to be thinking about the trig expression as the variable, and I'm going to worry about figuring out the value of x after I get it solved for the trig expression, okay, or the trig function. So I'm going to do the same thing I would have done over here. I'm going to add cosine to both sides. Now, some people, when they see a cosine on either side, for some reason they think they can divide both sides by cosine, but you would never divide by x here, right? You'd be dividing out an x, and also you'd be getting an x underneath here. So that is not a solution, a way that we would solve this, right? You don't want to divide out the x. And remember, if you divide out an x, just like when you square an x or multiply by x, you can get extraneous solutions. When you divide by an x, you can lose solutions. So never, 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 never divide by an x or a cosine, unless it's not going to, like if it doesn't make it cancel out, then you're going to have problems. You're going to lose solutions and you might not get them back, all right? So the first thing I'm going to do is add cosine to both sides. And over here we get a 0. And I get 2 cosine x plus root 2. And of course, what am I going to do? I'm going to move the root 2 over here. And then we get cosine x is equal to negative 2 root 2. Okay, so this is not solved yet because I don't know what x is. I only know what cosine x is. And from here, I have to use my trig skills, okay? So for me, when I think about this one, I usually think about it like this because those are the same things. So I kind of unrationalize them because to me that makes it easier, because when I work with trig things, I don't think about them as rationalized, all right? So let's think about this for a second. So what I need to do is I need to find an angle whose cosine is 1 over root 2, but it's negative. Okay, so first of all, what we need to do is we need to be thinking about our 2 triangles that we know. So there's 2 triangles that everybody knows. It's this one. So these are pi over 2. I'm not pi over 2, pi over 4, right? So I made it real tiny to fit on the screen, but you get the idea. So that's a 90, 45, 45, right? Right triangle. That would be the sides. This one would be our pi over 3 and our pi over 6. And this one would be 1 root 3, 2, right? So we have to decide between these 2 triangles which one is going to give us this kind of ratio. And hopefully you can see this one doesn't have a root 2. It's obviously this triangle, right? And then we have to decide where am I going to draw that triangle. So there's 4 quadrants I can draw it in. I know that in quadrant 1, cosine is positive, so I'm not going to draw it there. In quadrant 2, cosine is negative, so I'm going to draw it there. All right, so here we are. I know that it must be a 1, 1, root 2 to get this guy. I know that this one is negative and this one is positive. Let me use a different color so that you can see what I'm doing here, because now I wrote all on top of each other because I have a very limited amount of space to write here, right? So this is the triangle we're looking at. So What angle is that? Well, I know that it's pi over 4, but in this quadrant. So that means that it is 3 pi over 4 is the angle that I'm looking for. That would be here, okay? So one solution to this would be 3 pi over 4. That would be okay. Now we also know that in this, between 0 and 2 pi, there's actually another place where cosine is negative. Not in this quadrant, quadrant 4, but in this quadrant, it is negative. So if I were to draw this triangle and make this one pi over 4, everybody knows that his cosine would also be negative 1 over root 2. And this guy is, of course, that one is the 5 pi over 4, right? So another solution to this equation is 5 pi over 4. Okay, so this one has two solutions between 0 and 2 pi. I know there's no solutions here and there's no solutions here because these would be positive cosines. So if they asked me, so if the directions were solve, and it was in the interval 0 to 2 pi, then these would be my solutions. Those are the only two solutions. But everybody knows that if I just spin around again, so if I do this one, and I keep spinning around and I come back to here, so it would be 3 pi over 4 plus another 2 pi, or in other words, another 8 pi. So 8, 9, 10, 11 pi over 4 would also have that same cosine because I can spin around as many times. Any coterminal angle, right, is going to have that same sine or cosine. So this one would be our solution between 0 and 2 pi. So most of the time, well, a good quantity of the time they ask you that one. They ask you that question. They ask you between 0 and 2 pi. Or they tell you, maybe they say between 0 and pi, in which case this would be the only solution, right? So you have to read the directions. I didn't say specifically which one I was doing. So if they don't say, if they just say solve, then what they want you to do is name all the solutions. Now we know since there's infinitely many solutions, writing all the solutions would be crazy, right? Not really a feasible option here because we would have to be writing till we die and we would never even finish it. So what are we going to do to talk about that? I'm actually going to think about this idea. I'm going to think about how every time I spin around 2 pi, that brings me back to the same place. I'm going to write the solution as an equation, or as an expression, I guess. It's not really an equation, all right? So for this one, I'm really going to use this same idea, because if I spin around 2 pi, or I spin around another 2 pi, or another 2 pi, it doesn't matter how many times I spin around this 2 pi, I'm going to get back to that same place. So I'm going to call this one 3 pi over 4 plus 2 pi k, where k is an integer. And so what's an integer? An integer is a positive or negative, well, we usually say whole number, right? You know, whole numbers are only the positive ones, but an integer is the whole numbers plus their opposites and 0. So if this were a 0, if k were a 0, that would work because that would be that one. If k were a 1, that would work because that would be that one. If k were a 2, that would work because that would spin it around again. So this describes all our solutions. But we also have to talk about these ones because it doesn't describe these ones. So we also have to say 5 pi over 4 plus 2 pi k. And these would be all the solutions. So when they ask you for all the solutions, or just say solve, like if that was just the directions, then this is what we're going to do. So what we're going to do is we're going to do it both ways. We're going to solve between 0 and 2 pi for each of the examples, and we're going to come up with the equation for them, each one, okay, so that we can see them all. All right, let's look at the next one. So there you go. This one, we collected up the things onto the same side and solved just like we would if they were x's, okay? Let's look at this next one. Now this one only has one trig function, so really what we're trying to do is get that trig function all by itself, right? So the first thing I'm going to do here is subtract 1 and divide by 3. Is it okay if I do it all in one step? I hope so. Well, I'm not actually going to subtract 1, am I? I'm going to add 1 and divide by 3. So I added 1 to both sides, and then I divided by the 3 to get the tan squared all by itself. Okay? All right. But the tan is now a squared thing. All right? So how do I get rid of the square? Of course, I want to take the square root. So I want to do the square root of tan squared x on this side. And of course, when I do square root, remember, this has two solutions, doesn't it? It has the positive and the negative one, because if I put, like if you say x squared is equal to 4, well, x could be 2, but it could also be negative 2. Both of those would work in there. And remember, the solution are the values that'll make the original expression true. So this has both a positive and a negative number that if I put it in there, it'll work. So opposites are going to work here, right? So I have to say plus or minus square root of 1/3. All right, so tan x is equal to plus or minus, the square root of 1 is 1, the square root of 3 is I don't know, so I'm going to call it square root of 3, okay? So I'm going to work with it here. So we have to go back to our triangles. Why don't I draw them here in case people, I suggest if you don't know them very well that you draw them out. I even might draw them out even if I am kind of good at it, because as your brain gets tired, it's going to be harder for you to imagine them. So the more of these that you do, or easier to get them confused too, right? So, you start thinking about a ton of different stuff. We'll call this one pi over 6 and this one pi over 3 because this one looks a little bigger to me. So here's our two triangles that we need to have in front of our face. Even though I know them well, oftentimes I just draw them out because it's so much easier to use my eyes than my imagination. So instead of thinking real hard, I know this is the triangle I want. I want the one whose opposite side is 1 and adjacent side is root 3. So obviously I can see from here that the one whose opposite side is root 3, adjacent side, I want the opposite side to be 1. The opposite side to be 1, is that what I want? Yes, and the adjacent side to be root 3 is pi over 6, okay? So this one, in quadrant 1, is where I'll draw the first one, right? Because tangent is positive there. So I want this one, 1 root 3 in quadrant 1. But this says plus and minus. So I know that tangent is positive here and tangent is positive here. So the first one that I know is good is pi over 6. So this guy tells me the reference angle that I'm looking for, okay? So the triangle tells me the reference angle, and I know that from this ratio. These signs tell me where do I draw it in my unit circle. So since they're positive ones, I know I want these two. So everybody knows that the first one is pi over 6, and this one is 5 pi over 6. The trouble is they also want these negative ones because of that square thing. So it means I also want these two. But they have to have the same size reference angle as all the other ones. So what angle is this one? Well, that one is, that one was 5 pi over 6. This one's 7 pi over 6. Someone should have spoke up about that. I hope you were screaming at the thing. But I got it right anyway because we needed both of them. But if I had only needed one, I would have been messed up, right? This one's the 7 pi. Hopefully you see that. That one's 7 pi. And this one is the 5 pi. All right? And then the last one over here, this would have been 12 pi over 6. So this one must be one less than that. So that one must be the 11 pi over 6. All right? So if we're solving between 0 and 2 pi, so if the directions were, then this one would have been the correct angles. If we are solving for all the solutions, what we have to do here is we have to write an equation that represents this. Okay? So what equation or what expressions am I going to write? Okay? Now tangent has a period of pi. So if you remember, it starts to repeat. Tangent looks like this when you sketch it. And, these are pi away. So you're going to start getting the same values every time you move pi away. All right? So for this one, instead of writing 2 pi k, I can just use pi k to talk about it. Now, the funny thing is, if I do this one, pi k, that's actually going to catch this one right here. This one and this one. It's actually going to catch these two because pi k would be 6, right? And so it's going to catch this one and this one. Do you see that? I actually don't need to write 4 equations for this one. Like I had to write 2 equations for this one because these are not a standard amount away. But for tangent, this one and this one are going to be the same distance away. They're going to be pi away. And then to get back to here again, it's going to be pi. See that? See how it's a straight line? So to get from here to here is going to be pi, and then, or here to here, exactly is what I should say. Here to here is going to be pi, and then to get to here is going to be pi. So I actually can just use pi, and I only really need to use these first 2 small ones. And the other one that I need to say is this one. And if you take a look, if I add 6 to the 5, that's going to get me here. And again, they're on this straight line. So if I'm here and I spin to here, that's pi. If I'm here and I spin to here, that's pi. Pi. If I keep doing that, I'll get all of those coterminal ones. So for tangent, we really only need to write 2 also. Okay, so that would be for all the solutions. All right, we'll do one more on this video and then we'll stop it and I'll do some more examples on another one. Okay, well, let's take a look at this last one that I have on the page. Now this one has 2 different trig functions on it. Now there's only a couple things that you want to do if you have 2 different trig functions. Either you need to use your identities to get rid of one of the trig functions, or you need to find a way to write it as factors so that you can use your zero product property. Okay, so hopefully everybody remembers that the zero product property is this idea that if you have 2 things set equal to 0, 2 things being multiplied that are set equal to 0, then one of them has to be 0, and either one of them being 0 would make the statement true. All right, so what I'm going to do first is I'm actually going to see if I can factor this. And if I'm going to solve an equation by factoring, generally I want it set equal to 0, right? That would be the first thing that we would do. And then hopefully from here you can see that I have a cotangent in each of these terms. So if you want to think about it as something like well, let's not even get it. I guess you probably can guess it. But if you have a question about it, you can email me if you don't know what I'm talking about. All right, so let's factor out the cotangent. So this has a cotangent and a cotangent. What's left here is a cosine squared x, and what's left here is a 2. Okay, now since these 2 things are multiplied together, once again, my zero product property says that one of these has to be 0 because those are the only numbers. The only number that you can multiply and get a 0 is a 0. So if I could figure out what makes this thing 0, or I could figure out what makes this thing 0, I'd have a solution to my equation. And that's exactly what I'm going to do. I'm just going to figure out what makes each of these things 0. Okay, so here we go. I'm going to do cotan x is equal to 0, cosine squared x minus 2 is equal to 0. So this one, again, I want to be thinking about what angle that is. Now, these triangles aren't going to help me in this one because, of course, a 0 doesn't show up on here, right? So what's the other ones that I should be thinking about where I can possibly get a 0? And hopefully you know it's these quadrantal ones. And hopefully you know that the x value is going to be our cosine, and the y value is going to be the sine, if you remember. So if I'm looking for cotangent, I want the cosine over the sine to come out to be 0. So that means I want the cosine to be 0. So where would the cosine be 0 here? Well, it would be not here because that would be 1 over 0, which is undefined. But this would be 0 over 1. Okay, and the other way that you can think about it is if you know your graphs of cotangent, well, you know that he's this picture, right? And where is that 0? This one's the pi over 2, right? So that's the other way you can do it. You can either do it with your quadrantal angles on your unit circle, or if you're really good at drawing the graphs and you are good at imagining them, you can do the same thing. So same thing for sine, right? Like I could look at this and see where sine is 0 if I were doing sine instead. Or I could look at my picture of sine x and say, oh, well, I know it's 0 here, here, and here. Okay, so you can use either method. It makes you happy. I think this is the one that usually people are quicker at coming up with. But if you had these little pictures in front of you, that would be good enough too. That would help you a lot. Okay, so I know that Mr. Rodriguez always does it this way. I tend to do it this way, but he almost always draws these little pictures. So, okay, so now I know, oh, what did I say? I know that it's going to be here and here, because those are the two places where cosine over sine is going to give me a 0. So that's going to be at pi over 2 and 3 pi over 2. Okay, so between 0 and 2 pi, those would be the values I'm looking for. Now this one is going to be cosine squared x is equal to a 2. So cosine x is going to be equal to plus or minus root 2. Now I was just looking to see if I copied it right, because I already know there's a problem with this one. Does anyone see it? Okay, let's take a look at our picture of cosine. What's my range for cosine? It's between -1 and 1. How big is root 2? It's a little bit bigger than 1, right? It's because root 1 would be 1, so root 2 has to be bigger than that, which means that you can't get a root 2 with cosine. So this one is actually no solution. There's no solution to this one, which means the only thing that'll make it 0 is if this one were 0. So this guy has to be the one that comes out to be 0, because there's no way to make this one 0. So the only two solutions between 0 and 2 pi would be these ones. So that would be if we were doing between 0 and 2 pi. And again, does anyone know the difference between these two symbols? So the bracket means included, and the parentheses means excluded. So if I had the bracket, and let's say that these two had been my two solutions, this one over here I would describe as 0, not 2 pi, because this one has a parenthesis at 2 pi. But if the bracket were at the 2 pi and this were the parentheses, then I would describe it as, 2 pi. So make sure that you're looking at which way the bracket goes to, because that makes a difference in your answer. Okay, so this is between 0 and 2 pi. Now all our solutions, again, cotangent has a period of pi, so you could just say plus pi k, and that would get all of them, because that would actually get you your 3 pi over 2 also, right? That would get all of them. So that's 3 examples. I'll do a few more examples in the next video, so make sure you check it out.